Hi, I'm Mike Roumeliotis and I'm going to present a wearable embedded system providing tactile and kinesthetic haptics feedback for 3D interactive applications. Existing haptic devices that provide both tactile and kinesthetic feedback are heavy, expensive and often grounded, limiting users' motion. Thus, we have developed an innovative wearable embedded system on a glove that provides scalable tactile feedback through 15-coin vibration motors and kinesthetic feedback through an exoskeleton and 5 servo motors. We currently discuss ideas for future work. How does the kinesthetic feedback work? When the virtual finger collides with a virtual object, the servo motor, indicated by the number 1 on the picture on the right, rotates. Then the braking mechanism part, number 2 on the picture, blocks the rotation of the gear, number 3 on the picture. Then the finger stops moving. Now we are going to see the glove in action. We created a 3D escape type game in order to present some features of our glove. On the first task, the user needs to insert his hand in the scanner. He will feel vibration as his hand is being scanned. On the second task, the user needs to pull 3 levers to open a balcony door. Then he will feel both tactile feedback through vibrations and kinesthetic feedback as his finger's movement is blocked when he grabs the levers. On the third task, the user needs to place 2 spheres on a platform in order to reveal a secret code for the fourth task. He will feel both tactile and kinesthetic feedback similarly to the previous task. On the fourth and final task, the user needs to insert the code by pressing the buttons. He will feel tactile feedback in 3 different levels of vibration, depending on the power of the impact between the finger and the buttons. In the future, we plan to create a more compact PCB, which will include the microcontroller unit. We will redesign the servo motors into smaller units in order to reduce the bulkiness on the hand. We will utilize machine learning algorithms for hand tracking. We will use sound waves created by touching object as input to the vibration motors. We will adjust the stiffness of the servo motors to provide feedback on the softness or hardness of objects. And finally, we will make the device wireless so that the user is not constrained by cables. Thank you for watching.